Okay, let's do some review for this first test. All right, so we went over in class, we went over all of the things that you need to know how to do and the vocabulary that you need. So we're going to apply these now. So the first thing we have to do is evaluate for the given values and simplify. Of course, that means I'm going to replace the variables with the values given, and then I'm going to find out what the result is. Okay, so if I have 3x minus 4y, if I have x equals negative 3 and I have y equals negative 5, then every place I see an x, I'm going to replace it with negative 3. Every time I see a y, I'm going to replace it with negative 5. So this is going to be 3 times something minus 4 times something. So x is negative 3, whoops, and y is negative 5. So now I just follow my order of operations, which means I have to do the multiplication first. So 3 times negative 3 gives me negative 9, minus 4 times negative 5 is negative 20. That gives me negative 9 plus 20, which is 11. Okay, same thing here. If I have a minus 2b over 2 plus a, wherever I see an A, I'm going to replace it with a 2, and wherever I see a B, I'm going to replace it with a negative 5. So, I have A minus 2 times B divided by 2 plus A. So, a 2 goes here, negative 5 goes here, and 2 goes here. Now when I'm simplifying this, I want to remember that this fraction bar is a grouping symbol. So I have to do everything in the top, everything in the bottom, and then I am going to do my division. So this becomes 2 minus negative 10 divided by 2 plus 2, which becomes 2 plus 10 divided by 2 plus 2. 2 plus 10 is 12, 2 plus 2 is 4, and that takes me to my final answer of 3. Okay, if I want to translate from a statement to an algebraic expression, I can do that. But what I need to do is pay particular attention to what the words mean and the order. So if I start out with 5 more than something, that means I'm going to add 5 to something. And if I have twice a number, that's going to be 2x or 2n or whatever. If I have the difference of two numbers, of course, difference means subtraction. And then two numbers, I don't know what either of them are, so I can just write that as x and y. It doesn't say anything more specific than that. All right, if I want to distribute, that means I take what is outside the parentheses and I multiply everything inside by that number. So 2 times x gives me 2x. 2 times negative 4 is negative 8. And I'm done. Over here it's the same thing, but remember I'm distributing the negative sign as well. So that means I'll be changing the sign of everything. So negative 2 times 3 gives me negative 6. Negative 2 times negative 5 gives me a positive 10y. And negative 2 times x is a negative 2x. If I want to factor something, I'm basically undistributing. It is the reverse of this. Distributing is multiplication, so factoring is in essence division. So I find out what's in common to both of them. So I'm going to write down, I know that 3 and 9 have a 3 in common. So that's what comes outside. And then I'm going to divide each of these terms by 3. So 3 divided by 3 gives me 1x, or just x. Negative 9 divided by 3 gives me negative 3. If I'm undistributing, I have to find something in common to all three of these. Well, I know that 4, 6, and 2 are divisible by 2, so I'm going to write that outside my parentheses. And then I divide each of these by 2. And remember, you can always check these by multiplying it back out. If I multiply 3 times x, I get 3x. 3 times negative 3 is negative 9, and that gives me what I started with. So 4 divided by 2 gives me 2a. Negative 6 divided by 2 gives me negative 3b. And anything divided by itself is 1. You can't just get rid of that. You have to put it as 1. And you can check that by distributing. So that if I multiply, that gives me 4a, negative 6b, and 2. If it's asked me to find the factors of each number, that means find all the numbers that divide 46 evenly. So on this, I always do a table. Okay, so 46, I know the first factor pair in all of them is 1 times 46. Then I just start looking for other numbers that divide 46. I started with 1. This is an even number, so it's divisible by 2. And that gives me 2 times 23. Now, I would keep trying and trying, so I'd go to 3. It is not divisible by 3. It is not divisible by 4, or 5, or 6, or 7. And I get to the point where I think, well, 23 is a prime number, which means there's no other factors that go in this. But when it says find the factors of each, that means I list them. So I start here, and my list has 1 and 2 and 23 and 46. So this is my answer. So make sure that this is a list. 28 we did in class, but let's just do it again. I know 1 times 28. It's an even number, so it's divisible by 2, so that's 2 times 14. It is not divisible by 3. It is divisible by 4, so that is 4 times 7. It is not divisible by 5. It is not divisible by 6. And you can just test that on your calculator. And then I'm up to 7. 7 is already a factor, so I can quit now. But in order to list them, I list 1, 2, 4, 7, 14, and 28. The prime factorization is different. For the prime factorization, we need to be able to rewrite the number as a product of prime numbers. It may be 2 of them, or 3 of them, or 5 of them. It doesn't matter. Okay, or it could be none. If it's a prime number. Okay, and this is where I would use my ladder. Or if you're using factor trees, it works. To me, it's just less efficient. Okay, so 46. It's an even number, so I know it's divisible by 2. When I do that, I get 23 because I'm dividing by 2. 23 is a prime number. So you're done. So So my prime factorization is just 2 times 23. Do the same thing with 28. 28 is an even number, so I know it's divisible by 2, which gives me 14. That's still an even number, so it's divisible by 2. And I get 7, and I know 7 is prime. So I'm done. So my prime factorization is 2 times 2 times 7. Okay, let's talk about number sets for a little bit. All right, now, one of the things that we had issues with in the homework, and this makes perfect sense of it, don't feel bad if you didn't get this. So I've got all these numbers up here, and if I do my number sets, I'm going to start out, and the smallest group of numbers is the natural. And that's 1, 2, 3, 4, 5, the counting numbers. Then our next biggest group is the whole numbers, which is all the natural numbers plus 0. Then my next group is the integers, which is all the whole numbers and their opposites. So this is where we include the negative numbers. Then our next group is the rationals. And this is any number that can be written as a fraction, including repeating decimals, terminating decimals. Those can all be written as fractions. And then off to the side over here, you have the irrationals. And those are numbers that cannot be written as fractions, which include square roots of non-perfect squares. It includes non-repeating, non-terminating decimals. Okay. So the first thing I want to do when I look at a group of numbers is I want to look at the square roots. Well, the square root of 5, 5 is not a perfect square, so this is going to be irrational. But the square root of 1 is equal to 1. So it is a rational number. All right. So which ones are natural numbers? Okay, well, the natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the natural numbers, this is negative, that doesn't work. This is a fraction, so that doesn't work. 0 is not included. This is not included, but 1 is. So the square root of 1 is a natural number. This means that it goes on forever without repeating, and this is a repeating decimal. So this is the only natural number. Okay, the whole numbers, now if it's a natural, that means it's also a whole number. So whatever goes in here goes in the next group. So the square root of 1 is a whole number. And then I look for any other whole numbers that are not natural. And the only one is 0. So the integers, anything that's a whole number is also an integer, and anything that's natural is also a whole number. So I know my integers are the square root of 1, 0, and then I look for any numbers that are integers that are not in these groups. Well, the first one I see here is -3. So -3 is an integer. 2/3 is not, the square root of 5 is not, this number is not, and this number is not. So now I go to the rational. Well, it includes all the integers. The rational, anything that's inside it is also a rational. So this is the square root of 1, 0, -3. And then I'll look for numbers that are rationals that are not integers. So now we're going to go to 2/3. That is irrational. That is irrational. But 5 with 2 repeating is a rational. Okay. Now once you know the rationals, the irrational are everything else. So the irrational numbers are the ones that I haven't included so far, which is the square root of 5 and -2.329084 on forever. But which of these are real numbers? Well, they all are, because the irrationals and the rationals together make up the real numbers. So just for time's sake, I'm going to say, all right, well, all of them are real numbers. Okay, if I want to find the absolute value of a number, remember the absolute value is the distance from 0 on the number line. Direction doesn't matter. And distance is always a non-negative number. So if I'm looking at this, the absolute value of -12 is just 12, because it is 12 units away, but to the left. The absolute value of 0 is just 0. There is no distance between 0 and 0 on the number line. And the absolute value of 7.5 is just 7.5. So you'll notice that all of these are just non-negative numbers. Okay, on the inequalities, if I want to fill the blanks with less than or greater than, there are a couple ways I can do this. I can look at a number line and find their positions on the number line. So I can do this. I'm just going to draw a number line here. And I'm about to go from -12 up to 7. So let's do 0, 5, 10, -5, -10. All right. So if I'm looking at -12 and -5, -12 is here, -5 is here, which means -12 is less than. If I'm looking at -2.5, that's right here, and -3 is right here, so -2.5 is greater than -3. It always points to the smaller one, or the one to the left. And if I have 4 and 7, 4 is to the left, so 4 is less than. Okay, if I want to find the opposite of a number, that just means I change the sign. So the opposite of -12 is 12. The opposite of 2/5 is -2/5. And again, remember, you can put the negative sign in the numerator, out to the side, or with the denominator. And the opposite of 0 is just 0. You can't have a -0. Now the reciprocal is when you flip it upside down. So you would take this and put it over 1, so the reciprocal becomes 1 over negative 12. But notice the sign stays the same. You're just taking the whole thing and flipping it upside down. 2/5, the reciprocal is 5/2. And the reciprocal of 0, I would have to turn this into a fraction, so that would become 1 over 0, but that is undefined. Or there is no reciprocal. Okay, so I'm going to change videos now.